Okay, so I'm working problem 73 on page 163. This is an acid-base reaction. We have hydrochloric acid reacting with barium hydroxide. They're both in aqueous solutions. The question asks, which concentration is in excess at the end of the reaction? Would we have more H plus ions, or would we have more OH minus ions? And what would the concentration be of the excess? So we write out the chemical equation and we balance the chemical equation. So in this case, we'll end up with 2HCl plus BaOH taken twice. This will produce BaCl2 plus 2H2O. And we were giving the volumes and molarities of both reactants. So we can use the relationship of molarity equals moles of solute divided by liters of solution. And we can rewrite this equation as N equals V capital M. That way we can determine the moles of each of the reactants from the volume and molarity of each of the reactant. And we can do so, for example, hydrochloric acid, we were given 0.075 liters, and make sure you're in liters, not milliliters. So we were given 0.075 liters of hydrochloric acid, and we can multiply that by 0.25 molar, or we can rewrite the unit capital M as moles per liter, and we can determine the moles of HCl to be 0.0188 moles of HCl. We would do the same thing to barium hydroxide. We have 0.225 liters, and we multiply it by 0.0550 moles per liter. And when we multiply, we end up with 0.0124 moles of barium hydroxide. Once we find both the moles of each of the reactants, then we want to look at which one of these reactants is going to be the limiting reactant and which one would be the substance in excess. We can find out the limiting reactant multiple ways. I'm going to use the following. I'm going to try to do it in one shot. So you could choose either moles. I'm going to start with barium hydroxide. So we calculated 0.0124 moles of barium hydroxide. So now to determine the number of moles of HCl required to consume 0.0124 moles of barium hydroxide, I have to go back to the balanced chemical equation and use the molar ratios. So in this case, I know that I have 2 moles of HCl for every mole of barium hydroxide. And when I carry out this calculation, I find out that I would need 0.0248 moles of HCl. So now, to determine the limiting reactant this way, I would look and see I need 0.0248 moles of HCl to fully consume 0.0124 moles of barium hydroxide. So here is the trick. If the initial amount of hydrochloric acid is greater than 0.0248 moles of HCl, then HCl would be in excess. And if the initial amount of HCl is less than 0.0248 moles of HCl, then HCl is the limiting reactant. So when we look at the initial calculation that we did, we calculated from the information given that we only start with 0.0188 moles of HCl, which is less than 0.0248 moles of HCl. So that means that HCl is going to be my limiting reactant, and barium hydroxide is in excess. Now that I know that barium hydroxide is in excess, I want to find out exactly how much barium hydroxide actually reacted in this reaction that took place with the hydrochloric acid. So in order for me to do that, I will begin in the actual given moles that we calculated of HCl. So that would be 0.0188 moles of HCl, and then I will multiply it by, we have 1 mole of barium hydroxide per 2 moles of HCl from the balanced chemical equation. So when we multiply across, we end up getting 0.00940 moles of barium hydroxide. This is the actual amount that reacted. So in order for us to determine what's in excess at the end, we will take the initial amount of barium hydroxide, which we calculated at the beginning, and it was 0.0124 moles of barium hydroxide. And then we subtract what reacted, and that was the 0.00940 moles of barium hydroxide. And the difference it was what's going to be suspended in the solution, what's going to be dispersed, what's in excess. And the difference should be approximately 0.003 moles of barium hydroxide. Now from here, okay, remember, this is the excess of barium hydroxide. The question wants to know the concentration of the OH ions in this case, since it's in excess. So to determine the OH ions, we can do so. We just calculated that we have 0.003 moles of barium hydroxide that is in excess. So I know that I have 2 moles of OH ions from this chemical formula. I have 2 moles of OH per 1 mole of compound, BaOH taken twice. So I have 2 moles of OH ions per 1 mole of compound. And when we multiply across, we should end up with, I'm going to go ahead and put this in scientific notation. We should end up with 6.0 times 10 to the minus 3 moles of OH. Now I have the moles of the excess OH. So if I want to know what is the concentration, remember we have it right here. The concentration is the number of moles divided by liters of solution. So my concentration now of OH ions would be the moles, 6.0 times 10 to the minus 3 moles of OH. But now the question is, what is the volume? The liters of solution would be the combined initial volumes, the 0.075 liters from the hydrochloric acid aqueous solution, and then we add it to the 0.225 liters that comes from the barium hydroxide solution. So when you add both, you'll end up with 0.3000 liters of solution. And when you divide these two numbers, you should end up with the concentration of hydroxide, which in scientific notation, I'm going to write it as 2.0 times 10 to the minus 2 moles per liter of hydroxide ions, or molar, or you could write it as 2.0 molar OH ions.